Namaste, welcome back to the Pragna channel. You are watching AWS Certified AI Practitioner Exam Question Analysis playlist, and this is our second video. And Happy New Year to every one of you. This is our first video in the new year. I've been slacking these days. I think since last 2 weeks I haven't uploaded any new video because I was traveling and I couldn't. Here we go, and at least until we get on track, I am planning to release one video every day. We'll see how it goes. And this is our second video in this particular playlist. And if second or third video, maybe third video. And everyone who actually wrote this exam has cleared the exam so far. So congratulations for all of them. You can even read the comments under these videos to see how many people passed, and even I get emails personally where they mention that they passed this exam successfully. So I have read around at least 10 emails from 10 different people. So these are some new questions. I think we have about 30, 35 plus questions. I am planning to cover all of them in this video. In one video, I don't want to make another video. So brace yourself for 30 plus questions, and here we go. This question asks which type of prompting attack specifically exposes the underlying configuration or behavior set by the prompt template in a large language model. Here are certain things. Maybe you might have already know this or might not. Here is chance to learn this. Option A, prompted persona switches. This attack involves tricking the LLM into switching to a different persona or role that it wasn't explicitly programmed to adapt. While this alters the model's output behavior, it does not necessarily expose the configured behavior, because we are interested in this one. Behavior or underlying prompt template directly. This doesn't do that. Okay, so this is incorrect because this is focusing on role changes, not exposing the prompt template. There might be another question AWS can ask by switching configured behavior to role changes, then you should pick option A as the answer. And exploiting friendliness and trust. This type of attack manipulates the LLM by exploiting its programmed traits such as friendliness or trustworthiness to generate unintended or sensitive outputs. While it influences behavior, it does not directly reveal the prompt configuration itself. Again, this is not correct as it targets the model's social traits. Again, if AWS asks you a question where it is talking about social traits, then this attack would be your answer. And option C, ignoring the prompt template. This refers to scenarios where attackers attempt to bypass or ignore the designed structure of a prompt. However, this action does not explicitly expose the LLM's pre-configured behavior or the actual prompt template details. So this is incorrect as well, as it avoids the template without revealing it. So that leaves us with option D, extracting the prompt template. This attack directly involves attempts to uncover or expose the underlying prompt template used to guide the LLM's responses. This is a direct exposure of the configured behavior, and it is often done by reverse engineering or carefully crafted queries designed to elicit the template structure. So option D is the correct answer, as it specifically aligns with the question's focus on exposing the configured behavior. This question asks which security responsibility falls on the company when using Amazon Bedrock, which is a fully managed service that allows building and scaling AI applications. Okay, now, since you already know this is a fully managed, as the name itself says, fully managed, which means AWS fully manages it for us. Now let's go through the options and figure out which one is the responsibility. the company's responsibility or our responsibility. Patching and updating the versions of Bedrock. What do you think? Bedrock is fully managed, which means AWS is responsible for patching and maintaining the underlying infrastructure, including service versions. The company does not need to handle updates for Bedrock itself. So this is a Gano. It's not correct, as this is AWS responsibility under the shared responsibility model. If you are not aware of what shared responsibility model, then I would suggest you to first write the CLF, the Cloud Foundation practitioner exam, because that covers it extensively and I have explained it million times in there. Option B, protecting the infrastructure that hosts Amazon Bedrock. Anything that says infrastructure, forget about it for fully managed services and serverless services. The infrastructure hosting Amazon Bedrock, including physical servers, network hardware, and the underlying AWS cloud platform, is maintained and secured by AWS. Customers are not responsible for this aspect, so this is also not correct, as AWS handles this responsibility as well. Option C, securing the company's data. Of course. Remember, data, anytime you see data, it's always going to be the company's responsibility. It's not AWS responsibility. While AWS provides tools and mechanisms for encryption and data security, the customer is responsible for enabling the encryption, managing keys, and ensuring their data is secured in transit and at rest. This aligns with the shared responsibility model in AWS, where AWS secures the infrastructure and the customer secures their data. So this is the right answer, where it's company's responsibility, not AWS responsibility. So as securing the company's data is the customer's responsibility. And option D, of course, this has to be incorrect. Bedrock is what? It is a fully managed service provided by AWS, and it does not require customer to provision it within their own networks. The service runs on AWS infrastructure, and provisioning is managed by AWS. So this is AWS responsibility, not company. So that is incorrect. And AWS might ask you another question where it might switch AWS responsibility, and any A, B, D can be the answer. So what is our answer here? Option C. Okay, that's why it is very important for us to go through all the options and learn them, because that's what AWS does. Here C is the right answer, then AWS will switch this question in such a way that A, B, D can be the answer. Okay, and that's why don't memorize the questions, learn the concepts. That's why I'm here to make these concepts or explain these concepts as easy as possible, so that you guys can learn and use that knowledge writing your certification exam, or clearing your interviews, or maybe at your work. This question asks for the least operational overhead strategy to evaluate the toxicity of generated output from LLMs available on Amazon SageMaker Jumpstart. Option A, crowdsourced evaluation. This involves using a distributed group of individuals, usually from Mechanical Turk workers, to evaluate the outputs of the LLMs for toxicity. While it provides diverse feedback, managing and coordinating a crowdsourced evaluation process can result in significant operational overhead, including worker recruitment, quality control, and data aggregation. So this option is not correct, as this has higher operational overhead. Option B, automatic model evaluation. This uses pre-built algorithms or tools. For example, there is something called toxicity classifiers. There are some classifiers to assess the generated output from the LLMs. This is computationally efficient, easy to scale, and it does not require significant manual intervention, making it ideal for minimizing operational overhead. So I think this would be the answer, but let's go through C and D. Option C involves hiring a team of human evaluators to review and classify the generated output for toxicity. While this approach ensures accuracy, it requires significant manual effort, coordination, and time, leading to higher operational overhead. So eliminate this one as well. And option D, RLHF, which is sophisticated technique used to fine-tune LLMs based on human feedback. While effective for improving model behavior, it involves complex workflows, including collecting feedback, training models, and iterating on the process. This makes it one of the most operationally intensive strategies. So we'll eliminate that as well. That leaves us with option B as our right answer, as it offers the least operational overhead by automating the evaluation process. The question here describes a security testing scenario where a company tries to bypass the safety features of a foundational model to generate harmful content. The goal is to identify which security technique this represents. Fuzzing training data to find vulnerabilities. Fuzzing involves providing random, malformed, or unexpected inputs to a system to uncover vulnerabilities. It focuses on testing input data rather than directly attempting to bypass safety mechanisms to create harmful content. So this is not a correct answer, as it does not involve circumventing safety features. A DDoS attack is an attempt to overwhelm a system or application, making it unavailable to users. This is unrelated to testing or bypassing safety features to generate harmful content. So this is also incorrect, as this refers to availability disruption, not content manipulation. And penetration testing involves authorized simulated attacks to identify vulnerabilities. While penetration testing could include testing safety mechanisms, the specific act of bypassing safeguards to generate harmful content aligns more closely with a specific jailbreaking technique. You might have heard about jailbreaking your phones, right? So what are you doing? You are bypassing. If you are jailbreaking Apple phone, you are bypassing Apple's whatever thing that is there to freely download all the paid apps, etc. It applies here as well. So even option C is not the right answer, as this is a broader concept and it does not explicitly describe bypassing safety mechanisms. So the answer has to be jailbreak, option D. Jailbreaking refers to intentionally bypassing or exploiting the safety features or guardrails of a system, including foundation models, to make them perform actions or generate outputs they are designed to avoid, such as harmful content. This exactly matches the scenario described. So option D is the correct option, as the scenario explicitly involves bypassing safety features, which is a characteristic of a jailbreak. This question asks, which solution ensures that SageMaker training and inference jobs run in an isolated environment without internet access to meet regulatory requirements? SageMaker Experiments is a tool to organize and track machine learning experiments, including datasets, code, and parameters. It does not provide features for network isolation or meeting regulatory requirements related to running jobs in isolated environments without internet access. So option A is incorrect, as it is unrelated to network isolation or regulatory compliance. Option B, network isolation, enabled by using Amazon SageMaker's VPC mode, that's a setting. This ensures that SageMaker training and inference jobs run in a VPC without internet access. This satisfies the requirement for an isolated environment and aligns with regulatory compliance. So option B is the right option or the correct option, as it directly addresses the need for isolation and no internet access. And option C, encrypting data at rest, ensures data security, but it does not address network isolation or internet access restrictions. Geospatial capabilities are specific to location-based applications and are unrelated to the general isolation requirements for SageMaker jobs, so eliminated. This is not correct as it focuses on encryption rather than network isolation. And finally, option D, IAM roles are used to manage permissions for SageMaker jobs, but they do not provide network isolation or ensure the jobs run in an environment without internet access. While necessary for secure access, they do not fulfill the specific requirement for an isolated environment. So this is also not correct, as IAM roles manage permissions, but they do not isolate jobs from the internet. So what is the right answer? Option B. The question asks for a solution that allows an ML team to audit custom ML models when sharing them with other teams. The team retains the training code and data and wants a mechanism to document the model's life cycle for transparency and auditing. And how do you do that? Option A, storing documents in S3 is a basic approach to managing information, but it lacks the structure, versioning, and auditing features needed for a robust model auditing system. Manually creating and maintaining documents is also prone to inconsistencies. So I wouldn't pick this one as it does not provide a systemic or efficient mechanism for auditing models. You need a store that can actually is specific to storing models. For example, if you pick Amazon ECR, that is specific to storing containers. Similarly, do you know anything that is specific to storing the models? Of course, that is going to be the answer, but let's look at options and figure out. Option B, AWS AI service cards provide high-level transparency for AWS managed AI services, detailing performance and limitations. However, they are not designed for custom ML models developed by individual teams and are therefore not applicable to this use case. So this is also not correct, as AI service cards are for AWS services, not custom models. And Amazon SageMaker model cards are specifically designed to document details about ML models, including intended uses, training datasets, evaluation metrics, and inference environments. They help maintain transparency, enable audits, and support collaboration across teams. This aligns perfectly with the requirement to build an auditable mechanism for custom ML models. So I guess this is it. The model cards for models, ECR for containers. So this option is the correct option, as SageMaker model cards provide a structured solution for documenting and auditing models. And option D has to be incorrect. While versioning training scripts in a Git repository is good practice for code management, but it does not inherently document or audit the broader aspects of a model, such as intended use, evaluation metrics, and inference details. Like, I mean, you won't store containers in Git, but let's say an artifact repository, you can still store it, but ECR is specific to containers, right? So that would be better suited. Similarly here as well. So this is a partial solution and it does not meet the requirements fully. So this is not correct as well. It addresses code versioning, not model auditing. So what is the right answer? Option C. This question asks for a solution that uses AI to increase software development productivity for a company building tools for customers. Option A binary classification model classifies data into two categories. All right, binary is like 0 1, so two categories: yes, no, true, false, male, female. All those are considered as binary. All those comes under here. So here we need to figure out for example, issue or no issue. While it could be used for basic code analysis, it is not designed to improve overall development productivity, as it does not assist with tasks like writing, refactoring, or recommending code. So this is incorrect. as it does not directly address the broader need for increasing productivity. Code recommendation software. This integrates into developer tools to suggest code snippets, auto completions, and improvements, effectively streamlining development tasks. This approach directly aligns with the goal of increasing productivity by making the development process faster and more efficient. Okay, so this is the correct answer, as the solution directly improves developer productivity. So what is an example of a code recommendation software? So if you are using, I mean, this is AWS, so do you know any service that comes to your mind that exactly does this? Yes, the code whisperer, which exactly uh, developers can use to improve their development productivity. All you need to do is enable it, whether it is Lambda or whatever you are trying to write. So once it is enabled, all you need to do is enter a comment and it will give you the code for that. If you don't know how to use that, etc., again, you can check our projects playlist. We have overall 100 projects, real-time projects that are designed by AWS, but I have done them. More details can be found in the playlist for those projects, and those playlists are available in the description. The links are available in the description of this video and any other video. So you can go ahead and check it. But what I'm saying is, you know, you use Code Whisperer. Actually, I kind of use it at work as well. Yeah. And recently, I think there is something called Q Developer as well, but I have never used it yet. I use Code Whisperer while writing Lambda code. Now, option C, that has to be incorrect. But why? Because code forecasting tools predict potential issues in code but focus on improving code quality rather than productivity. While this is also valuable, they do not address productivity enhancements like code generation or recommendation. Okay, this is more about issue prevention than overall productivity improvement. And NLP tools can generate code based on natural language inputs, which can assist in development. However, this approach may be less precise and harder to control compared to integrated recommendation tools. While it can be part of the solution, it is less tailored to daily developer workflows. So this is not the best choice, as it may not fit seamlessly into existing developer tools compared to option B. So the right answer is B. The question asks which type of data is suitable for SageMaker Deep AR forecasting algorithm, which is used for predicting future demand for a specific product. Now, option A, text data consists of words and sentences typically used for applications like NLP tasks, for example, sentiment analysis, language translation, and etc. It is not relevant for forecasting product demand, which involves numerical or temporal patterns. So this is not correct, as text data is not suitable for deep AR forecasting. Image data, how about that? Image data is used for computer vision tasks such as object detection or classification. Forecasting algorithms like deep AR are not designed to process image data for time-dependent predictions like demand forecasting. So this is also not correct, as image data does not meet the requirements for deep AR. How about time series? Of course, time series data consists of sequential data points indexed by time, such as daily sales or product demand over time. The deep AR algorithm is specifically designed to forecast future values based on time series data, making it ideal for this use case. So this is correct, as time series data is the required input for deep AR. Finally, binary data. This typically represents two state variables, example true, false, on, off, male, female, and it is not suited for the type of sequential numerical analysis required for demand forecasting. So this is not correct, as binary data does not align with the requirements for deep AR. So the right answer is C. The question here asks what a retail bank should do to develop an unbiased ML model to assist with loan allocations decisions for different demographics. Reducing the size of training dataset would lead to less data for the model to learn from, potentially degrading its performance. This does not directly address bias and might even worsen it due to insufficient representation of minority groups. So this is not the correct answer, as it does not help reduce bias and may harm model performance. And ensuring consistency with historical results could reinforce existing biases in the historical data, especially if past loan allocation practices included biased decision making. This approach risks perpetuating systemic biases instead of mitigating them. So this is also not correct, as it may lead to biased outcomes. Building separate models for each demographic group might lead to fairer results for each group individually. However, this approach could lead to other issues such as maintaining multiple models and potential overfitting due to smaller data sets. It does not inherently solve the issue of bias in the training process, and it may introduce other complexity. So this is also not correct, as it is not a practical or standard method to addressing bias. So that leaves us with option D, that has to be the right one. Um, Class imbalance. This occurs when some groups or categories are underrepresented in the training data. Measuring and addressing this imbalance, such as by resampling the data using appropriate weighting or applying fairness constraints, ensures that the model does not learn biased patterns. An example would be like male and females in military, right? We all know that the majority group who participates or joins military is male. So now when you want to try to do some predictions or analysis or something based on that data, it will be biased because you will have more data for males and less data for females. So you know that kind of situation. So it will have a class imbalance there. So this is the right answer, as it directly addresses bias by ensuring balanced representation in the training data. Okay, so D is the answer. The question asks, which prompting technique can help protect against prompt injection attacks? A scenario where malicious input manipulates an LLM's behavior by injecting harmful instructions into the prompt. Yeah, that can happen. We will see going forward, right? Because GPTs are fun, famous right now, and people will come up with all kinds of attacks. Anyways, and going forward, everyone, we should include something in our resumes saying like I'm a prompt engineer. That is a thing now. Okay, companies are looking for better prompt engineers because everyone knows that AI tools are integrated into the tools that you are using to code. So the better a person or a developer is at prompting these uh, you know uh, AIs, or not AIs but the GPTs or whatever it is, the better code you will write and faster you will write. So don't forget to put prompt engineer in your resume. Anyways, adversarial prompting. This involves crafting inputs designed to test and expose weaknesses in a model's behavior, including potential vulnerabilities to prompt injection. By simulating malicious inputs during testing, this technique can identify and mitigate risk before deployment. This is what we are looking for. So, of course, this is the right answer, as adversarial prompting is specifically used to guard against vulnerabilities like prompt injection. Zero-shot prompting provides a single query or task without any prior examples or context. While this method can be efficient, it does not inherently address or mitigate risks related to prompt injection attacks. So this is not correct, as it does not specifically protect against prompt injection. Least to most prompting involves starting with simpler questions and progressively increasing the complexity. This technique is designed to improve task accuracy but it does not focus on mitigating prompt injection vulnerabilities. So this is also incorrect, as it does not directly address prompt injection. Chain of thought prompting structures the prompt to encourage step-by-step reasoning for complete complex tasks. While useful for improving model outputs, it does not provide specific protection against prompt injection attacks. So this is also incorrect, as it does not focus on security against prompt injection. So what is the answer? Adversarial prompting. The question here is asking which metric the company should use to evaluate whether fine-tuning an LLM for a help desk has improved the model's accuracy in answering questions or not. What is the metric? These metrics we have discussed about this in previous videos, so go check that out if you haven't learned what these metrics do or is about. Precision, what does it do? It measures the proportion of correct positive predictions, which, for example, like the correct answers out of all positive predictions made by the model. While it evaluates one aspect of accuracy, it does not consider whether the model misses relevant answers, which is nothing but recall, right? Precision alone may not fully capture the overall effectiveness of fine-tuning. So I would say this is partially correct, but not the best metric to evaluate overall accuracy improvement. Time to first token. This measures the latency of generating the first token in a response. It focuses on the speed or responsiveness of the model rather than its accuracy in providing correct answers. So this is also not correct answer, as it measures performance speed, not accuracy. F1 score is the harmonic mean of precision and recall, providing a balanced measure of a model's accuracy. It considers both how many relevant answers the model identifies, which is recall, and how many of its predictions are correct, which is precision. This metric is widely used to evaluate the accuracy of question answering models and is well suited for assessing fine-tuning improvements. So this is the correct answer, as it provides a comprehensive evaluation of accuracy. This has to be a wrong answer. Word error rate, or in short, WER. This is commonly used for evaluating transcription tasks such as speech to text models. It measures how many words in the output differ from the ground truth. While useful for transcription accuracy, it is not relevant for assessing the accuracy of answers in a question answering context. So that's incorrect, as it is unrelated to the task of question answering. So what is the answer? Option C, F1 score. The company uses RAG, or retrieval augmented generation, with Bedrock and stable diffusion to generate product images, but finds the results random and lacking specific details. The question is asking which solution would improve the specificity of the generated images. Option A, increasing the number of generation steps in stable diffusion allows the model more iterations to refine the image. While this can enhance the image quality and detail, it may not directly address issues with specificity, especially if the input prompt or guidance scale is insufficient. So this is not the best solution, as it improves quality but not necessarily specificity. The mask image black option is used for in-painting tasks where specific regions of an image are masked and regenerated. This feature is unrelated to improving the specificity of an image generated from a text description. So this is also not correct, as it addresses in-painting rather than specificity in text to image generation. And the CFG scale, the classifier free guidance scale, what does it do? It controls the balance between adhering to the text prompt and exploring creative randomness. Increasing the CFG scale makes the generated image align more closely with the text prompt, enhancing specificity and ensuring the details from the prompt are better reflected in the image or not. So that is what the question is asking, right? This is the correct answer, as increasing the CFG scale directly improves alignment with the text prompt, increasing specificity. So sure, why not? That makes option D incorrect. Why? Because prompt strength typically affects the weight of the text input in influencing the output. While this can improve specificity, it is more relevant in scenarios where prompt guidance competes with other factors such as prior image context in painting. For general text to image tasks, increasing the CFG scale is a more direct and effective approach. So I don't think this is the best solution, as CFG scale is a more targeted fix for specificity issues. So C is the right answer. The question here asks for the most cost effective solution to implement a LLM based chatbot that provides real time contextual responses using the company's policies as the knowledge base. Retraining an LLM from scratch involves using vast computational resources and large data sets. This approach is both expensive and time consuming, especially for leveraging pre-existing knowledge while incorporating a relatively small knowledge base like company policies. So I think this is not a cost-effective solution, as retraining is unnecessary and resource intensive for this use case, which will increase the cost as well. Fine-tuning involves adapting the LLM by training it on the company's policies. While more cost-effective than retraining, it still requires significant computational resources. Additionally, fine-tuning locks the model to specific data, making updates or dynamic changes less flexible. So this is not the most cost-effective solution, as it incurs higher costs than alternatives like retrieval based methods, which we'll look at in a minute, or right here. RAG, or retrieval augmented generation, combines LLMs with a retrieval mechanism to fetch relevant knowledge, for example the company policies, dynamically at inference time. This method avoids the need for retraining or fine-tuning the LLM, making it highly cost effective. It also ensures flexibility, as the knowledge base can be updated without modifying the LLM. So I think this is the right answer, as RAG balances cost effectiveness, flexibility, and accuracy for contextual responses. So that makes option D incorrect. Pre-training is the initial training phase for LLMs, typically on massive data sets. This approach is highly resource intensive and unnecessary when working with a pre-trained LLM. Data augmentation may improve training, but it does not improve training. It does not directly address the need for cost-effective real-time contextual responses. This is not a correct answer, as pre-training is prohibitively expensive and unnecessary for this use case. So RAG is the right answer here. The question asks, which AWS service can assist a company with minimal programming experience in using Glue to create a new solution? I think I might have given away the answer in one of the other questions, which is the Amazon Q developer. This is a, if you are new to AWS, this thing they added it 3-4 months ago. And along with those updates, they changed the UI of so many things, including Lambda, which I didn't like the new UI, by the way. If you like it, it's your choice, but I didn't like it. They still have the option of switching to old one, and they ask us a feedback like, why did you switch to old one? I'm like, I didn't like it. Anyways, so they introduced Amazon Q developer into pretty much all the tools. So what is this? This is a generative AI powered assistant that helps users build, extend, and operate AWS applications, including providing software development assistance. It is specifically designed to help users with tasks related to AWS, such as understanding AWS services, creating code, and offering best practices. For a company with minimal programming experience, Amazon Q Developer is an ideal solution. because it provides conversational assistance to understand and use Glue. It can generate code snippets, offer completions, and even debug and optimize code for AWS Glue workflows. Its integration with IDE simplifies the development process for beginners. So basically, this service aligns directly with the company's needs for using AWS Glue effectively with minimal programming expertise. That makes all this incorrect. And config is a service for tracking and auditing configurations of AWS resources. It is unrelated to using or simplifying AWS Glue for ETL or data processing tasks. So that is not correct because it doesn't assist with Glue. And Personalize is a machine learning service for building personalized recommendations, and it does not provide tools or guidance for using Glue. It is unrelated to the company's goal of creating a solution with Glue. And Comprehend is an NLP service used for extracting insights and sentiment analysis from text. It does not provide tools or guidance specific to using Glue as well. So what is the answer? Q developer. This question asks which principle of responsible AI the company demonstrates by ensuring a diverse data set, which you can see here, of insect bite photos that includes representation across genders, ethnicities, and geographic locations. Which principle of AI? Is it fairness? Fairness in AI involves ensuring that models do not exhibit bias and provide equitable outcomes for all groups. I think this is important. If you remember, I think in the beginning of, I don't remember if it is Gemini or Copilot or Chat GPT, but whenever people used to ask about, this is, I mean, in US, about Democratic Party, it used to give answers like Biden if you ask Biden and all. But if you talk about Trump, it doesn't. And there was another example, weird example that I have seen recently. I think it is Gemini, where um, you can, is it Gemini or something? I don't remember, but there was this GPT where you can actually, yeah, I think it is not related to any GPTs, but I think Coke, okay? So Coke has introduced this new feature, Coke COK, wherein you can go to these machines where you can add any word that you want on your Coke tins. The vending machine will print that name on the Coke tin and gives it to you. But whenever somebody tries to put Jesus, it doesn't do that. It will throw a message saying blah blah blah. You can watch videos on YouTube as well. So that is something that is biased, okay? Because it is not giving outcomes for all the words that you are trying. It's not even a bad word, but right? Jesus is not. Everyone knows that. But when you input that, it doesn't. It just throws some weird mirror message. Whoever came up with that, trained the GPT or anything that runs behind the scenes to identify what are the words they are trying to do, they specifically, I guess, excluded these words. I guess there was a big thing that went on about this, like why are they targeting Christians and whatnot. But this is an example where the model, it is exhibiting bias. But fairness is something that makes sure the models do not exhibit bias and it will provide equitable outcomes for all groups. Doesn't matter if a Christian, Muslim, Hindu, anybody else, it treats everyone the same. It did. I mean, humans are biased on several things: country, color, religion, income levels, whatnot. But if the models are doing the same, I mean, makes sense, right? Who trained the models? Humans. So I wouldn't be surprised. Um, so by using a diverse data set representing different genders, ethnicities, and geographic locations, the company aims to reduce bias and make the model equally effective for all users, regardless of demographic factors. This directly aligns with the principle of fairness. So yes, this is the right method to do. That is the principle of responsible AI, fairness. But I guess there are exceptions, I am assuming, as the company demonstrates fairness by ensuring inclusivity and reducing bias in the model. And option B, explainability. This refers to the ability to understand and interpret how an AI model makes decisions. This principle involves making the decision-making process transparent and understandable, which is unrelated to the company's effort to use a diverse dataset for reducing bias. So this is not correct, as the scenario does not address the explainability of the model. And governance in AI involves establishing policies, frameworks, and oversight to ensure responsible development and deployment of AI systems. While governance may support the use of diverse data sets, it does not directly describe the company's action of collecting diverse data to reduce bias. So this is also not correct, as this scenario focuses on fairness, not governance structures. And finally, transparency involves providing clear information about how an AI system is built, how it operates, and its limitations. While transparency is important, it is not directly demonstrated by the company's action of collecting a diverse data set for training. So this is also incorrect, as this scenario does not directly address transparency. So what is the answer? Answer A, fairness. Not just AI models, even humans needs to have this principle, so called fairness. Okay, you should never, if you are hiring, let's suppose you are in a company and hiring someone, don't go try to hire people from your ethnicity or people from your country or your language, or just hire them based on their skills. That's what we should be doing. Same thing. Okay, whether you are how you treat some person, don't treat them based on their looks, their dressing. They can, whether if you the ability to speak certain language that you speak or not. So don't, even humans need this principle, which is fairness. I wish everybody had it by default, but well, it is what it is. This question asks which solution can help a company both detect bias in an ML model and explain the model's predictions, specifically for a loan approval system. And which tool can help us with this? And it so happens the name of this one is called Clarify. And what do we want? We want the ability to explain the predictions. The SageMaker Clarify is specifically designed to help identify bias during data preparation, training, and inference stages of ML models. It also provides tools for model explainability, such as feature attribution, which helps explain how each feature impacts the model's predictions. This directly aligns with the requirements to detect bias and explain predictions. So this is the right answer, as SageMaker Clarify addresses both bias detection and explainability effectively. Data Wrangler simplifies the process of preparing and transforming data for ML, including cleansing and feature engineering. While it aids in pre-processing, it does not provide tools for detecting bias or explaining model predictions. So this is incorrect. It focuses on data preparation, not bias detection or explainability. SageMaker model cards, we learned in one of the previous question, is used for documenting model details, including intended use, training datasets, and evaluation metrics. While they promote transparency and governance, they do not include tools for detecting bias or explaining predictions. So this is also incorrect, as it is not designed for bias detection or explainability. And then we have AI service cards. This provides transparency for AWS managed AI services, detailing performance, limitations, and responsible AI practices. These cards are not specific to custom ML models, and they do not offer bias detection or explainability tools. So this is not correct, as they are unrelated to custom ML model evaluation. So what is the answer? SageMaker Clarify. The question asks which metric the company should used to evaluate the accuracy of the model. Evaluate the accuracy of a generative text summarization model developed using Bedrock. AUC score. AUC or under area under the ROC score. This is used to evaluate the performance of classification models by measuring the ability to distinguishing between positive and negative classes. It is not suitable for generative tasks like text summarization, which involve evaluating text quality and relevance. So this is incorrect, as AUC is irrelevant for text summarization. F1 score, which we spoke about in one of the previous questions, is used for classification problems and evaluates the balance between precision and recall. While it can be adapted to evaluate aspects of summarization like overlap between predicted and reference summaries, but it does not fully capture semantic accuracy or fluency in text generation tasks. So this is not a best choice as it is not specifically tailored to generative tasks. Then what is? Well, that's where we have BERT score. This evaluates text similarity by comparing embeddings generated by a pre-trained language model like BERT. It captures semantic similarity between the generated summary and the reference summary, making it well suited for assessing accuracy in generative text summarization tasks. So this is the right metric as it evaluates semantic accuracy and relevance in text generation effectively. And real work knowledge score, it does not exist as a standard metric for text summarization. This option seems hypothetical or unrelated to evaluating text summarization models. So this is not correct. It is not a recognized metric as far as I know. So what is the right answer? BERT score. This question asks for the most suitable algorithm to classify flowers based on their petal length, petal width, sepal length, and sepal width. This is a classification problem. So which algorithm will you choose for a classification problem? Option a KNN, which is a supervised learning algorithm which is used for classification and regression. It predicts the class of a new data point by analyzing the classes of its nearest neighbors in the feature space. This algorithm is well suited for classification problem like this one, and it clearly mentioned classification of flowers. So this is the right answer, as KNN is a reliable algorithm for flower classification based on features. Why not K-means? Because this is an unsupervised algorithm used for clustering, not for classification. It groups data into clusters based on feature similarity, but it does not predict classes for labeled data. Okay, so supervised learning means you will give it labeled data. Unsupervised learning means it learns the features on its own. You don't give it. So this is incorrect, as K-means is used for clustering, not classification. And ARIMA, auto-regressive integrated moving average, this is a time series forecasting algorithm used for analyzing and predicting temporal data. It is unsuitable for classification tasks involving static features like flower dimensions. This is not correct, as ARIMA is unrelated to classification tasks. Finally, linear regression. This is a supervised learning algorithm used for regression tasks. Okay, predicting continuous numerical outputs. It is not appropriate for categorical outputs like flower classes. This is not correct, as linear regression is not for classification. So the answer is KNN. The question asks which AWS service the company should use to manage a company managed encryption key for encrypting model artifacts created by custom models in Amazon Bedrock. And everyone knows the answer when it comes to encryption keys. Which one? Of course, it's going to be KMS. key management service. The name itself says that. This is a fully managed service for creating and managing encryption keys. It integrates seamlessly with other AWS services, including Bedrock, to encrypt sensitive data like model artifacts using customer managed keys, or CMK in short. This directly meets the company's requirements for encrypting model artifacts, so this is correct, as KMS is explicitly designed for encryption key management. Why not this? Well, Inspector is a security assessment service that identifies vulnerabilities in AWS workloads, and Macy is a data security service that uses machine learning to detect sensitive data, such as PII data like personally identifiable information in S3 buckets. And finally, Secrets Manager is used to securely store and retrieve secrets such as API keys and database credentials. That's why they are not the right answer. KMS is the right answer. The question is asking which feature of LLMs can convert natural language code comments into code generation. Which one of them? Interesting. Do you think it's interesting? Let's see. Summarization, text summarization. This involves condensing text into a shorter, concise form while retaining the key points. It is not suitable for generating executable code from natural language, right? Summarization always means you have 10 paragraphs, you summarize it into one paragraph. That's not useful for producing code that you want to execute. This is incorrect as it focuses on summarizing text, not producing code. So the answer has to be generation, right? Text generation, it involves producing coherent and contextually relevant text based on a given input. This includes generating code from natural language descriptions as the model produces new content aligned with the input prompt. This aligns perfectly with the requirement, so this is our correct answer, as text generation is used to create code from natural language input. Why not text completion? This involves predicting and appending text to a partially written input. While this can assist in writing code by completing snippets, it is not explicitly designed for generating new code from natural language. This is kind of partially correct, but not the best choice, as it focuses on completing input rather than generating code from scratch. How about text classification? This assigns labels or categories to text, for example, spam detection, sentiment analysis. It does not involve generating text or code. This is unrelated to code generation. So what is the answer? Text generation. The question asks which metric the company should use to assess whether the LLM, whether the output of a LLM aligns with examples of more readable versions of text for a language learning app. Which metric? Value of the loss function. This measures how well the model fits the training data during training. While it's important for model optimization, it does not directly evaluate the coherence or readability of generated text compared to examples. This is not correct, as it is a training metric, not an evaluation metric for coherence. What about semantic robustness? This measures a model's ability to maintain meaning under adversarial conditions or input noise. It is not specifically designed for evaluating how well the output resembles provided examples of more readable text. So this is not correct as well, as it is unrelated to assessing text coherence or similarity to examples. How about rogue score? Recall oriented understudy for gisting evaluation. Rogue, it measures the overlap between generated text and reference text, focusing on precision, recall, and F1 score for text similarity. It is commonly used for summarization and aligns well with the task of ensuring the generated text matches the readability and coherence of provided examples, which correctly matches with our requirements. So this is the correct answer, as Rogue effectively evaluates similarity between the LLM's output and the provided examples. Latency of the text generation. Latency measures the time it takes for the model to generate text. While important for app performance, it does not evaluate the coherence or resemblance of the text to provided example. So this is not correct, as it is a performance metric, not a content evaluation metric. So what is the answer? Rogue score is the answer. The company wants to modify the prompt techniques to reduce the generation of unrelated images by its foundational model. How do you do it? Which prompt do you use it? I think we learned about zero shot prompt in one of the previous question in the same video. Do you remember? This involves the zero shot prompt involves asking the model to generate outputs without providing any examples or context. That's why it's called zero shot. This technique relies on the model's pre-trained knowledge, but it does not improve specificity or alignment with the prompt. In fact, it may result in less relevant outputs. So this is not correct, as zero shot prompts are less likely to reduce unrelated image generation. How about native prompts? Native prompts specify what should not appear in the generated image, helping refine and focus the output by excluding unrelated or undesired elements. This technique directly addresses the issue of generating unrelated images and ensures closer alignment with the desired content. This is the correct answer, as native prompts help steer the model away from generating unrelated images. If native prompts is correct, positive prompts is incorrect. This provides detailed instructions about what should appear in the generated image. While they are essential for guiding the model, they do not explicitly address the issue of excluding unrelated elements, making them less effective in the specific context. So this is not the best choice, as positive prompts alone may not sufficiently reduce unrelated content. How about ambiguous prompts? This provide vague or unclear instructions which are likely to exacerbate the problem of generating unrelated images. This approach is counterproductive to the company's goal. So even this is not the right answer. So what is the right answer? Using negative prompts is the answer. The question asks for the best prompt engineering technique. You see, right? Prompt engineering technique. I think this is the fourth question on this topic. To generate concise and feature specific description for company's products using a LLM. Option A, creating a single prompt for all products and manually editing the responses introduces inefficiency and inconsistency. While it centralizes the initial input, the lack of specificity may result in overly generic or less relevant description. So this is not the right option, as it does not align with the goal of creating concise and feature specific descriptions efficiently. So eliminate it. And option B, this particular approach ensures that each product category is addressed with tailored prompts focusing on its key features. Specifying the desired output format and length ensures consistency, consciousness, and alignment with business goals. This balances efficiency and specificity, making it ideal for generating conscious features focused description. So I think this is the right answer, as it effectively meets the requirements in an efficient and organized manner. While including diverse features, may generate unique descriptions. It risks producing verbose or unfocused outputs. This approach may compromise consciousness and specificity, which are core requirements. So this is not a right answer, as it prioritizes creativity over consciousness and specificity. And finally, option D, while detailed product specific prompts ensure precise and customized outputs, they can be time consuming and less scalable for companies with many products. This method sacrifices efficiency for precision, so this is not the best choice, as it is less efficient compared to category based prompts. So what is the right answer? Option B. The problem described here indicates that the ML model is overfitting. Why? Because it performs well on the training data set but fails to generalize to new data, and we call that overfitting. Now, the question is asking for the best solution to resolve this particular issue. And guess what? We have dealt with overfitting questions in the machine learning specialty, like 10 or 15 questions. And even in this previous video, not videos, we have dealt with overfitting as well. Now, Sitapragnas, I hope you have already answered this question correctly here. If not, I would want you to go to question number 1 and watch all the questions again. Decreasing regularization parameter reduces the penalty for model complexity, allowing the model to fit the training data even more closely. This exacerbates overfitting, making the problem worse. So this is not the right answer, as it increases overfitting. So if it is not decreasing, then what fixes it? Increasing the regularization parameter. It penalizes model complexity, encouraging the model to generalize better by preventing it from overfitting the training data. This approach can help the model perform better on unseen data. So this is the right answer. What do you do to handle overfitting? You will increase the regularization parameter. Now, answer C, adding more features. This will just increase the dimensionality of the data, which can lead to the model fitting spurious patterns, further worsening overfitting and making the model complex, right? Unless the new features are highly relevant and improve the signal to noise ratio, this is not an effective solution, and eliminated. Finally, option D, train the model for more epochs. This allows it to continue learning from the training data, which can lead to further overfitting. This would worsen the generalization problem as well. So just increase the regularization, that makes the model more generalizing. So what is the answer? B. The company requires an AWS database service that supports storing and querying embeddings as vectors. A common requirement for AI applications like conversational search. So which tool will you use? Very easy. If you can eliminate Athena and EMR way, because EMR is not a database, Athena is not a database, right? We are looking for a database service. Redshift, which is a data warehouse, but I mean, I don't see any reason why you cannot use it, but let's go through these two. And Athena, as I mentioned, right? What is it? It is an interactive query service for analyzing data stored in S3 using SQL. It is not designed to store or query vector embeddings effectively, so forget about it. And EMR is a managed big data service that supports distributed processing frameworks like Spark. While it is powerful for large-scale data processing, it does not provide direct support for storing or querying vector embeddings. That is what we want to do, querying and storing vector embeddings. Now, between B and C, Redshift, we already know it's a data warehouse which is optimized for analytics at scale. While it supports SQL-based queries, it is not specifically designed for storing and querying vector embeddings. Then what is? Of course, this is. Aurora PostgreSQL supports storing and querying embeddings by enabling the use of PG vector, an extension designed for vector similarity search in PostgreSQL. This makes it a suitable choice for applications that require query embeddings as vectors. So this is the right answer. Option B is the right answer, as Aurora PostgreSQL with PG vector meets the requirements for vector storage and querying. The question asks which factor relates to the explainability of an AI solution's decisions in the context of a foundation model used for loan approval decisions. So, this is like what, third or fourth question on loan approval decisions in the same video. Interesting, don't you think so? I guess there are too many loans that are going on these days. All right, model complexity, it refers to the intricacy of the model structure, such as the number of layers in a neural network or the number of parameters. Complex models are often harder to interpret and explain because of their black box nature. Simpler models are methods to simplify complex models, enhance explainability by making decisions easier to understand and audit. Okay, so this is the right answer because as model complexity directly impacts explainability. Training time refers to how long it takes to train the model. While this is important for resource planning, it is unrelated to the explainability of models' decisions. So this is not correct, as training time does not affect explainability whatsoever. And number of hyperparameters refers to tunable parameters set before training, like learning rate, batch size. While these can influence model performance, they do not inherently relate to how explainable the model's decisions are. This is also not correct, as hyperparameters are unrelated to decision explainability. And finally, deployment time refers to how long it takes to move the model into production. This factor is relevant for operational considerations but has no connections to the explainability of the model's decision. So this is incorrect answer. So what is the answer? Model's complexity. This question asks for the best solution to analyze user reviews of medications and provide concise summaries for each medication. Time series forecasting models are used to predict future trends based on temporal data. Amazon Personalize is a recommendation system service which is unrelated to summarizing textual medication reviews. This is not correct, as it does not address summarizing reviews. Amazon Bedrock, which provides access to pre-trained foundation models including LLMs, which are highly effective for text summarization tasks. LLMs can analyze user reviews and generate concise feature-specific summaries for each medication. So this is the right option, as it directly aligns with the requirement to create medication review summaries. A classification model categorizes data into predefined classes or groups. While it could group medications based on review content, it does not generate summaries and it is not suited for the specific requirement. So forget about it. This focuses on categorization, not summarization. And then we have recognition. This is an image and video analysis service used for tasks like face detection and object recognition. It is not designed for analyzing text or summarizing medical reviews. So this is not correct, as it is unrelated to text summarization. So what is the answer? Option B, using Bedrock LLMs. The question asks which ML model type allows employees to view and adjust weights assigned to variables in the model, enabling domain knowledge and expertise to influence predictions for a lead prioritization application. Okay. The logistic regression model is a linear model that predicts probabilities for classification tasks. Its weights are what they call coefficients are interpretable and can be adjusted based on domain expertise. This transparency makes it ideal for scenarios where employees need to understand and tweak the model based on variable importance. So I guess this is the right one, as logistic regression meets the requirement for interpretability and adjustability. Why not deep learning model? Deep learning models are highly complex and often considered black box models. While they can be powerful, they lack transparency, and adjusting individual weights is impractical for non-specialists. Incorporating principal components further complicates interpretability. So this is not the right answer for this particular question because it does not provide interpretable or easily adjustable weights. And KNN is a non-parametric model that makes predictions based on the similarity of data points in the feature space. It does not use weights or coefficients for variables, making it unsuitable for scenarios requiring adjustment of weights. Forget about it. And neural networks are complex models with many layers and parameters. While they are powerful for complex tasks, their weights are not interpretable, and manual adjustment of weights by employees is infeasible. So this is not right answer, as neural networks lack transparency and practicality for manual weight adjustment. So what is the right answer? Logistic regression models. The question asks for the best strategy to determine whether a foundation model effectively meets business objectives. Evaluating a model on benchmark data sets measures its general performance, but it does not directly assess its effectiveness in meeting specific business objectives. Benchmarks are useful for comparing models, but may not reflect real world use cases or objectives. So this is not correct answer for this question, as it evaluates general performance, not alignment with business needs. Analyzing the model's architecture and hyperparameters provides insights into how the model operates, but does not evaluate whether it fulfills specific business objectives. These details are more relevant for optimization, not determining business alignment. So this is also incorrect. And option C, assessing the model's alignment with specific use cases, which evaluates how well the model supports the organization's business goals. This involves testing the FM in real-world scenarios or simulated environments to ensure it effectively delivers value and meets business objectives. So this is the right answer for this question, as this directly ties the model's effectiveness to its ability to meet business needs. And finally, option D, measuring computational resources is important for cost and deployment planning, but it does not assess whether the model meets business objectives. Resource efficiency does not guarantee effectiveness in achieving business goals, so that is incorrect. So option C, models alignment to specific use cases, is the right answer. The question asks which type of learning the company should use to train an ML model to classify images of animals, given that the data set is already labeled and the company will not label additional data. And we already know that when you already have labeled data, we are looking for a supervised algorithm or supervised learning algorithm. We already know that. This is kids question, don't you think so? Supervised learning uses labeled data to train models. Since the dataset is labeled and the task is image classification, supervised learning is the most appropriate method. The model learns by mapping input data, which are images in this case, to corresponding labels, which are types of animals. So this is the right answer, as supervised learning is ideal for labeled dataset and classification tasks. Why not unsupervised? Because this deals with unlabeled data and aims to discover patterns or structures in the data, such as clustering or dimensionality reduction. Since the data set is labeled, unsupervised learning is not appropriate for this task. And reinforcement learning involves training agents to make sequential decisions by maximizing rewards in an environment. It is not suited for tasks involving static labeled data sets. And finally, active learning is a technique where the model selectively queries an oracle, example a human labelers, for labeling additional data to improve performance. Since the company has already stated it will not label more data, active learning is not suitable. So, what is the right answer? Supervised learning. The question asks which phase of the machine learning life cycle is responsible for determining compliance and regulatory requirements. Feature engineering involves transforming raw data into features that can be used to train the model. While important for model performance, this phase does not address compliance or regulatory requirements. So eliminate this one. Model training is the process of teaching the ML algorithm to find patterns in a customer data to make predictions. While this phase ensures model performance, it does not include evaluating compliance or regulatory requirements, so forget about this as well. Data collection involves gathering data to be used in the ML process. This phase includes ensuring that the data is collected and used in compliance with regulatory requirements such as GDPR or HIPAA. It is crucial for determining whether the data source and usage meet compliance standards. So, even though all that is fine, but I still think this is partially correct as data compliance is addressed here, but it is often influenced by business goals. So that's what this option D is. Identifying business goals is the initial phase where the overall objectives of the ML project are defined. This includes assessing compliance and regulatory requirements to ensure that the project aligns with legal and ethical guidelines. These requirements often drive decisions across the ML lifecycle. So option D is the right place. Right phase is the phase where compliance and regulatory considerations are typically determined. So the answer is D. The question asks for the best solution to help a food service company develop an ML model that can reduce daily food waste, increase sales revenues, and continuously improve the model's accuracy. How do you do that? Personalize gone, CloudWatch gone, recognition gone. SageMaker, of course, we are going to use SageMaker because this provides a comprehensive platform for building, training, deploying ML models by continuously incorporating new data like daily sales, food waste metrics. The company can retrain and refine the model, improving accuracy over time. This approach aligns with the need for continuous improvement and handling dynamic data. Why not personalize? This is optimized for providing personalized recommendations based on user behavior. While it could help increase revenue through recommendations, it is not designed for modeling operational metrics like reducing food waste or interactive or iterative improvement with new data. And CloudWatch is used for monitoring and logging AWS resources. Finally, recognition is an image and video analysis service. It is unrelated to tasks such as reducing food waste or building models for operational optimization. So answer is SageMaker. The question asks for the best solution to deploy an ML model for predicting real estate sales prices while avoiding the need to manage servers or infrastructure. They are just saying I use a serverless or fully managed service. And as soon as you see EC2, you know you need to eliminate it because this one involves infrastructure and management. And this one is talking about EKS cluster. This also involves managing infrastructure components, so forget about it. Even though EKS simplifies the deployment and management of Kubernetes clusters, managing EKS clusters still requires oversight of the Kubernetes control plane, worker nodes, and configurations, which involves infrastructure management, so we don't want that. And option C It is trying to use CloudFront with S3, which is ideal for serving static assets like files and images, but it does not provide the necessary capabilities for hosting and running ML models for prediction. So that leaves us with a SageMaker endpoint, which is kind of serverless service. This allows you to deploy ML models as fully managed services. SageMaker handles provisioning, scaling, and maintaining the underlying infrastructure, allowing the company to focus solely on making predictions without worrying about server management. So option D, SageMaker endpoints, is the right answer because these are purpose built for deploying ML models without infrastructure management. The company wants to develop an AI application for employees to check customer claims, retrieve claim details, and access related documents. The solution must efficiently manage and query this information. And how do you do that? Amazon Fraud Detector is designed for detecting fraudulent activities and is not suited for managing customer claims or assessing claim documents. While agents for Amazon Bedrock could assist with natural language queries, Fraud Detector does not align with the company's requirements. So forget about that. And agents for Amazon Bedrock enable conversational AI applications by interacting with large language models and integrating with knowledge bases. By connecting to knowledge bases, example databases or repositories with customer claim data, the system can efficiently query and retrieve claim details and documents, meeting all specified requirements. So this is the answer. If you are enrolled into CloudQuest, which is where you can actually do hands-on real-time projects, which is what our projects playlist will show you. Um, it has a projects on this knowledge basis. And option C, again personalized, we already know this. This is a recommendation engine for providing personalized suggestions such as product recommendations. It is not designed for claim management or querying documents. And even though SageMaker is a powerful platform for building and deploying ML models, training a custom model from scratch is resource intensive and unnecessary when existing solutions, which are agents for Amazon Bedrock, can meet the requirements without extensive development. So why not pick that? Answer is B. The question asks to identify the type of AI application used by a manufacturing company to inspect products and detect damages or defects. Which one? Is it recommendation engine? No, this suggests items based on user preferences or behaviors. You might have seen this in action while watching Netflix movies or Amazon, buying Amazon products on Amazon, right? You will see recommended product, recommended movies, shows, etc. That's a recommendation system or recommendation engine in action. And NLP focuses on processing and understanding human language like text analysis, chatbots. It is unrelated to analyzing visual data such as product images for defect detection. So that's a goner. That is what we is computer vision. Computer vision, what does it do? It involves teaching machines to interpret and analyze visual data from images or videos. Inspecting products for damages or defects using AI falls under computer vision as it requires analyzing images to detect anomalies. So this is our answer. Why not image? Even here there is image. Well, image processing refers to techniques for enhancing or transforming images like noise reduction, resizing. While it can be a pre-processing step in computer vision, it does not involve detecting defects or analyzing images in the context of AI applications. So the answer is computer vision. A company wants to create an ML model to predict customer satisfaction. So the question is asking which service, AWS service, can create an ML model to predict customer satisfaction with fully automated model tuning. So we are looking for a service that can do all this. Is it personalized? Of course not. We already know what this is. This is designed for building recommendation engines. While it provides some automation for model training and tuning, it is specialized for recommendations, not general predictive tasks like customer satisfaction. Athena, we already know that it is an interactive query service for analyzing data in S3. And Comprehend, it is an NLP service for extracting insights from text. While it can analyze sentiment or extract key phrases, it is not designed for building and tuning custom ML models. So forget about it. That leaves us with option B. SageMaker, this is a comprehensive platform for building, training, deploying ML models. It includes SageMaker automatic model tuning, which automates the hyperparameter optimization process to enhance model performance. This feature aligns perfectly with the need for fully automated model tuning for customer satisfaction prediction. So B is the answer. The question asks which technique a company can use in post-processing ML lifecycle to lower bias and toxicity in generative AI applications. Option A, human in the loop, or in short it is also called HITL. This involves incorporating human feedback or intervention during or after the model's prediction phase. This technique is effective for post-processing to identify and mitigate bias or toxicity in model outputs. Humans can manually review and adjust outputs to ensure they align with ethical and unbiased standards. So this is the right option because this directly addresses bias and toxicity in the post-processing phase. What about data augmentation? This is a pre-processing technique that increases dataset diversity by creating modified versions of the existing data. While it helps address bias during training, it is not a post-processing technique. And feature engineering involves creating or modifying input features to improve model training. It is relevant during the training phase and it does not apply to mitigating bias or toxicity in the post-processing phase. And adversarial training involves exposing the model to adversarial examples during training to improve robustness. While it can help mitigate vulnerabilities and bias during training, it is not a post-processing technique. So the answer is human in the loop. The question asks how a bank can cost effectively address bias in a fine-tuned LLM that approves loans at varying speeds for different demographics. Again, loans. Even AWS certification is trying to make you take loans, but don't take loans. Everyone, guys, girls, stop taking loans. Okay? I have seen people taking even EMIs are considered as loans, just so you know, because people these days like buying iPhones on these EMIs wherein they are going to tell like, you know what, you don't have to pay $1,000 way ahead of time. You can pay like $50 every month. And a person who doesn't even earn $1,000 a month, I mean, most of the people can, but I'm just saying, for example, they'll be like, oh, I don't have to pay 1,000 right now, only 50 per month. That's fine. I can totally. But if you don't have the money in your account or with you, don't make a purchase. Doesn't matter whether it is a TV or a phone, bike, car. If you don't have the money, don't buy it. Loans are very bad. Trust me. Loans are very bad. By avoiding loans, I mean there might be some inconvenience for you. Maybe if you don't have a car, bike, but there are other means using which you can totally do that. This is not 80s or 19s. Okay, so try to avoid taking loans. Even if it is house loan, try to avoid taking it. Save money. Save money, invest it, then maybe use the money that you get to buy a house. But loaning is a very bad idea. I am a prime example. I'm telling you from experience. So don't take loans. Anyways, coming back to our question. Um, okay, yeah. Option A, adding more diverse training data addresses the root cause of the bias by ensuring better representation in the dataset. And fine-tuning the existing model with this improved dataset is of course going to be a cost-effective approach because it builds on the already fine-tuned model rather than starting from the scratch. Right? This is correct as it is a targeted and cost-effective solution to mitigate the bias. And RAG, it integrates external knowledge sources with an LLM for improved responses. However, it is not designed to address inherent biases in the model's training or decision-making processes. And Trusted Advisor provides recommendations for cost optimization, security, and performance improvements, but it does not offer tools for detecting or eliminating bias. I don't know why they even included that here. And pre-training a new LLM from scratch is resource intensive, requiring significant computational power and time. While it may address bias, it is not cost effective compared to fine-tuning an existing model at all. So what is the answer? Option A is our right answer. And the final question for today. The company wants to log all requests made to the Bedrock API and retain these logs for 5 years at lowest possible cost. What is the answer? And we already know if you want to store something somewhere, logs especially with the lowest cost, it has to be S3. And if you want to get the logs, what is the service you will use? And what are they saying? They're telling you to log all requests, API requests. And what better service than CloudTrail? Basically, CloudTrail records API calls and actions across AWS services, including Bedrock, and it provides a history of these events for auditing purposes. This is the correct service to log requests made to Bedrock APIs, so that's one option. CloudWatch monitors and logs metrics and application logs. It can store logs temporarily. It is not optimized or cost effective for long-term retention, making it unsuitable for 5-year retention requirement. Audit Manager helps automate audits by managing evidence collection and assessment frameworks. It does not log API requests. And S3, between these two, if you want to go for um, what is it? Lowest possible cost, which one will you pick? Standard or this? Standard, of course, it's the costliest among all S3 classes. So if when you compare between these two, I will pick option D. Why? Because we are using it to retain the logs, not to query it every day, right? Intelligent steering, it automatically moves data between storage tiers based on access patterns, minimizing storage costs. It is well suited for securely storing logs for long-term retention while optimizing costs for infrequently accessed data. Whereas S3 standard is ideal for frequently accessed data, but it is more expensive than intelligent tiering for long-term storage of infrequently accessed logs. So I would go with D. So what are our answers? A and D are our answers. And that concludes this video. I know it's a little bit longer, but I wanted to finish all these questions in one video. So here you go. I hope you will enjoy these new questions and new analysis. And if you did, don't forget to subscribe, like, and comment. And all the best for your exam. Don't forget to leave a comment on under these videos once you write your exams. Of course, it is going to be pass, and most of the people who wrote this exam after watching our previous videos, they scored 1000 out of 1000. So you are going to score 1000 out of 1000 as well. All the best. See you in other playlists and other videos. Thank you very much for spending your time here, and have a great day. Peace out. Love you all.